Okay, so we're going to do distances in space review, and I'm going straight off the order of the worksheet that I gave you guys. So the first one is, how long will it take a planet to orbit if its star is 23 AU away from the star? Let me make a copy of the question, actually. Okay, so write the question. How long will it take a planet to orbit if its star is 23 AU away from the star? So we got to use Kepler's law, because as soon as you see AU, okay, that means it's Kepler's third law. So p squared equals a3, a cubed. And remember, p is the period, the amount of time it takes. So this is your years. If it gave you days, in the case of something like Mercury, then you'd have to change it into a part of a year. And then the a is your astronomical units, your distance. Okay. So this is your distance and your time. Okay. So this is how long it takes, and this is how far away it is. And they gave us 23 AU, okay, which is your distance. That's your AU. So we want to rewrite, change the color back. Okay, so we want to know how long it's going to take. So we need to know the p squared. We'll take 23 and cube it. Okay, so I take out my little calculator. We go 23 cubed is 12,167. Okay, so p squared equals 12,167. Okay, then I want to take the square root of both sides. So square root. So now I'm going to take the square root of that answer, and it gives me 110.3. So the p equals 110. I'm just going to go 110. Okay, and then we have to have units on it. So this, remember, is how long it's going to take, and this is the period, and periods are measured in years. So it's going to take 110 years for this star to orbit the sun. Its star, not necessarily our sun. Right, let's go to the next question. Let me copy the next one. Next one says, how long will it take an asteroid from its star if it is 7.3 AU away from its star? Okay, so how long is it going to take if it's 7.83 AU? So this one should take a lot less time because it's a lot closer. So it's only 7.3 AU away. So we want to use the same formula. So I'm going to write it again. Okay, p squared equals a cubed, because we have 7.3 AU here again. So I know I have my AU, right, corresponds with this. So I'm looking for how long. So that's my p squared, my time, how long it's going to take to orbit. And then we're going to take 7.3 and cube it. Okay, and then I'll put it in my calculator, 7.3 cubed is 389.0. So I'm just going to keep it 389. Okay, and then I want to take the square root of both sides. So square root of p squared. So now I'll take that number I just did and the square root of it, and that equals 19.7. So this asteroid is 7.3 AUs away. It's only going to take 19.7 years to orbit its star. So much less time. Okay. Next question, let's go copy it. Now this one says, how far away is an exoplanet from its star if it takes 216 years to orbit? So now we have the years, we need to find how far away is it. So we want to find out how many AU it is this time. So copy it down. How far away is an exoplanet from its star if it takes 216 years to orbit? So same formula, still p squared equals a cubed, but now we have 216 years. That's my period. Okay, so this 216 is now going to go in my period. So I'm going to square 216. And that's going to give me my a cubed. Okay, so I put 216 in my calculator, square it. That gives me 46,656 equals a cubed. Okay, now instead of a square root this time, we have to do a cube root because this is a cubed. We want a by itself. So we're going to take the cube root of it and the cube root of the 46,656. So I got to use my cube root function on my calculator. When I do, oopsies. I get 36 exactly. I did not pick that. It just happened that way. I didn't even figure that one out, people. It was just random. So it gave me 36 is A. But remember, A stands for my astronomical units. Make sure you put your units in your answer. So 36 AU is how far away this exoplanet is from its star. Okay. This works for every star. It's not just for our star. It works for any star. We can use this. Oops. We can use this equation. Okay, so I'm going to go copy the next one. How far away is a comet if it takes 92 years to orbit? Okay, so it's taking 92 years to orbit its star. So it's like Halley's comet, which is more like 80 some years. It's a little bit shorter. This would tell you how far away this comet is from the sun. This is a short term comet. There's also long-term comets that have years and thousands of years. They could be hundreds of years or thousands of years or just dozens of years. Depends on the comet. They're all different. So this one takes 92 years to orbit, a little bit longer, as I said, than Halley's comet, the most famous comet of all. Okay, so we want to know how far away is it. So, so that's our A. So we need to know the time. So we have 92 years. That's our period. Okay, so I'm going to square 92. And that's going to give us A cubed. Okay, so 92 squared gives us 8,464 equals A cubed. But remember, this is a cube, so a square root's not going to do it to find out what it is. So we got to have a cube root. You got to use your scientific function on that calculator, what you paid the extra $3 for in that calculator. So we want to take the cube root. When we do, we get 20.37. So I'm going to round that off to 20.4. So 20.4 AU away from the star. Okay. So if you look at this one, it's 92 years. It's 20.4 AU. If you look at the last one, took 216 years. It was more AU, right? So if I look at these other answers, I should start to see a pattern. This one was 7.3. It only took 20 years to orbit. So you can see, you can check your work with your other answers to make sure it's making sense. This one's 23 AU, and then it took 110 years, right? So the one that was close to that, okay, this was 110, it was 36. So it is, you can see that it's should have a pattern that it keeps getting bigger and bigger the more AUs, okay? And if one's out of that pattern, then something's wrong, okay? So if one's got a shorter distance but a longer time than another one, then you should see that there's something wrong with that and your calculation is incorrect. Okay, so that's Kepler's second law. So let's look at the next one. We're dealing with distances in space farther than in our solar system. So we want to use AU in our solar system, but outside of our solar system, then we got to go to the bigger light years. So it says, how far away is a star in kilometers if it is 10.7 light years away? When the distance light travels in a year is 9.5 times 10 to the 12 kilometers. Okay? And remember, it doesn't show me the 10 to the 12th, but this should be a 12th right there. So let me get my little tool. Okay, so this should be a 10 to the 12th. Okay, so we know that the distance light travels, and we know how far away this is. Okay, so we want to know, this is the distance, speed, time count triangle. Distance on the top, speed and time on the bottom. Okay, and it's saying how far. Okay, when I see how far, that's my distance. Okay? So I know it's distance because it's how far. We have the speed light travels in a year, so this is technically in 1 year. This is a speed. Okay, that's the speed light travels in 1 year. Okay, And we have the time. That's the 10.7 light years. Okay, that tells us how long it's been traveling for at this speed. Okay, so we want to know how far away that star is. So this is the speed of how fast light travels in a year. We have how long it's going to take, because remember, light years tells us the distance, but it also tells us how long that light's been traveling. So if we're looking for distance, look at your formula there. We're looking for distance. These two things multiplied is the speed times time. So we want to multiply speed times time. So my speed of light is 9.5 times 10 to the 12 kilometers in a year. And it's been traveling for 10.7 light years, because that's how long this light's been traveling for. We measured the light as 10.7 years to get to us. Okay, so now you have to do is multiply these two to come up with your answer. You can cross out your years, because your answer is going to be in kilometers, because we want to know how far in kilometers. So 9.5 times 10.7 gives us 101.65. That one came out ugly, I don't like it. And then the 10 to the 12 doesn't have anything to multiply, so it stays the same, times 10 to the 12. Okay, I'm going to put my kilometers on here because that's my distance. Units is kilometers. Okay, but I also want this to be in correct scientific notation. My scientific notation has to have the decimal after the first number that's not a 0. Okay? And that first number that's not a 0 is my 1. So my decimal needs to go here. So I need to move my decimal 2 places. So my answer is going to be 1.0, and I round this 1 off to 2 because there's a 6 behind it. Okay. So it rounded off to 2, or it moved 2 places, and I rounded it off. So it'd be, instead of 1.0165, I just rounded off to 1.02. Okay, the 3 sig figures. And then I moved 2 places to the left, so you can either think it's to the left, or I just look at my original number. My original number was 101, it was bigger, so I want to add those 2 spaces I moved. So 12 plus 2 gives me 14. So this 10 to the 12th is becoming 10 to the 14th power. So 10 to the 14th kilometers is the distance to the star. Okay, if it's 10.7 light years, that's how many kilometers it is. The next question asked you is connected to this question. It says, how long will light from this star take to reach us? Okay, so let me write this question here. So how long will it take the light of that star, this star from the previous question, to reach us? Well, it's going to take us 10.7 years for the light to reach us. So that's because that's how long it's traveling in a light year. Okay, it's traveling 10.7 light years of distance. That's also time. So it's going to take 10.7 years for this light to reach us. So if we were to send a message to that planet, that star orbiting that planet, and get the message back, we'd have to multiply it by 2, and that would give us 21.4 years if it was a round trip. So if we traveled at the speed of light to this planet, it would take us 10.7 years to get there, and another 10.7 years to get back. If we were traveling at the speed of light at 9.5 times 10 to the 12th kilometers in a year, which is impossible because we travel like super duper slow compared to that. Okay, and we'll talk about that more when we get to space travel. So let's look at question 7. How far a star away in light years if it's 6.2 times 10 to the 21st kilometers away? Oops. How far away is a star in light years if it's 6.2 times 10 to the 21st kilometers away? Okay, so this is now, we want to know the time on this one. Let me change to mine. Cool. Okay. So this is back to our distance, speed, time triangle. Okay. We have the distance, how far the star away is. This is that 6.2 times 10 to the 21st. Okay, we have the distance. Okay, we know the speed of light from the previous question, 9.5 times 10 to the 12th. We know the speed of light. This is in a year. Now we want to know the time. Okay, so what we're looking for this time is our time. How long is it going to take for that star in light years to get to us? Because if we know the time, we also know the amount of light years. Okay, so we're going to take this distance, change my color. Okay, so we know the star is 6.2 times 10 to the 21st kilometers away. And we know that light travels at 9.5 times 10 to the 12 kilometers in a year. So we're going to divide these two to figure out how many light years it is, how long it takes for that light to reach us. Okay, so the time. So we want to divide the 6.2 by the 9.5. So first let's divide the top by the bottom. 6.2 divided by 9.5. That gives us 0.65. Oops, I can just put it back in black. So 0.65. And then for the scientific notation, when we're dividing it, we want to subtract it. Okay. So we want to subtract the 10 to the 21 minus the 12. So 21 minus 12 gives us 9. Okay, so this becomes times 10 to the 9 light years. I'm going to put LY for light years, if I can write correctly. Okay. But we're not in the right scientific notation again. Okay. My decimal is not after my first number. So I need to move it so it's after the 6. It cannot have a 0 in front. It has to have one digit in front. So we want to move it one space to the back. So it becomes 6.5 times 10. Now this time, okay, I had a number less than 1, a small number. So instead of adding it, I would subtract that one space. So I moved. So it's 10 to the 8th light years away from Earth. So that tells us how long that light takes us, and it also tells us a distance. Okay, this is what's confusing about light years. It's two things at once. So this star is 6.5 times 10 to the 8th light years away from us. Okay? But it also takes 6.5 times 10 to the 8th years for the light from that star to reach us. Okay, so two things it's telling us at once. Okay, so the previous question, the next question is actually asking about our previous one. Okay, so let me put that up there. Okay, so it's saying, how long will it take the light from that star to reach us? Well, this is the answer right here. So the answer to that is this right here, is the 6.5 times 10 to the 8th, but not in light years now, just years. So it's going to take us 6.5 times 10 to the 8th years for the light from that star to reach us. Okay, so the previous question answered it, how much time it's going to take. Two more questions. How long will it take a signal to reach us if the spacecraft is 340 million kilometers away from us? And light travels at 3.5 times 10 to the 5th kilometers a second. So last time we're dealing in years. Now we're dealing with something in our own solar system, and we know how long is that spacecraft going to be able to, how long is it going to take that signal. So back to our distance, speed, time. We have the distance of how far away that spacecraft is from us. Okay, we have the speed of light. Okay, we want to know how long it's going to take. So we're looking for time on this one. So it's distance over speed. So follow your formula, distance over speed right there. So 340 million. It's going to take me a while to write because slow, slow, slow. So 340 million kilometers. And we're dividing it by the 3.0 times 10 to the 5th kilometers. Times 10 to the 5th kilometers in a second. And that's going to give us how many seconds? it's going to take us to reach us, this signal. Okay. So we want to divide 340 million, and you can do this in your calculator. If you put 340 million, then you can divide it, you can put 3.0, and then put the exponent to 5, okay? And it gives you 1,333 seconds. Okay, so there's two ways you can do this. I just put the two numbers in. You can change this to scientific notation, so change this to 3.4, okay, and then 3, 6, 7, 8 spaces, 3.4 times 10 to the 8th. Okay, and then you can just divide 3.4 by 3. That gives you 1.13 infinity. And then 10 to the 8th minus 10 to the 5th, so subtract those, gives you 10 to the 3rd seconds. Both answers are correct. Either one's good. They're exactly the same answers. As you can see, if I move this decimal 3 places over, it's going to give me 1,133.2. So either way is correct. Okay. Last question. How far away is the spacecraft if the signal takes 8 minutes and 27 seconds to reach us, traveling at the speed of light? How far away is the spacecraft if the signal takes 8 minutes and 27 seconds to reach us? In kilometers, if light travels at 3.05 times 10 to the 5th kilometers a second. This, remember, is a superscript. It's an exponent. Okay, so the signal is taking 8 minutes and 27 seconds to reach us. So this is back to distance, speed, time triangle. Okay. We have the speed of light, right? We know the speed of light, and we know the time. It's taking 18 minutes and 27 seconds. We're looking for distance this time. So we're going to multiply the distance by the speed. I'm sorry, the speed by the time to find the distance. And so we're looking for distance. The speed is 3.0 times 10 to the 5th kilometers a second, or 300,000 kilometers in a second. And we want to multiply this by the time, but the problem with the time is it's in 18 minutes and 27 seconds. So we want to turn this into seconds because the speed of light is in seconds. So I can't have minutes in there. So I need to multiply my 18 by 60 because there's 60 seconds in a minute. Okay? And then add that to the 27 seconds I already have. Okay? So I want to change my minutes into seconds. So I multiply the 18 by 60. Okay, that gives me 1,080. And I add that to the 27. Okay, and that tells us how many seconds it takes. And so it takes 1,107 seconds for this signal to reach us. And that's just one way, by the way. Round trip, it's going to take 36 minutes for the signal to reach us. We got to double that time. So I'm at 37 minutes. So we're going to multiply 3.0 times 1,107. That gives me 3,321. Okay, and I can cross out these seconds, by the way. And then 10 to the 5th doesn't have anything to multiply to it, so 10 to the 5th just stays. Okay, and my units are kilometers. Okay, now I want to change this to right scientific notation, so I'm going to change it. So my decimal needs to be after my first number, that's my 3. So I move 1, 2, 3 spots. Okay, so it becomes 3.321. And because my number was bigger than 1, I add my spaces. So it becomes times 10 to the 8th kilometers. Okay, that's it. And I'll send you a copy again of the document if you've lost it. And then you can see this. Have fun watching this on YouTube.